Hello, my name is Ilham HIDAYATULLAH and two of my group members, GANTAN ETIKA MURTY and ABDULGHANI AL-AMODI. Our group acknowledged this plagiarism declaration and we agree to comply with it. Thank you. Hello, so this is our sketch for the state diagram. This is for the MUR and this is for the MILI.
Hello, my name is GANTAN and I'm here to explain this state diagram. So this is our state diagram. We have 4 states. This is the exit condition of each state, D, D, D. In this case, our sequence is D, D, D. And this is the stay condition for each state. And once everything is done, the next state would be back to the first one. And this is the waveform. Let's simulate it first. So this is it. When we input all D, D and D, the output will be 1 after the third D button is pressed. But then it goes to 0 again once the reset button is pressed. And it is triggered by rising edge clock. Thank you. This is our MUR circuit. But first we need to simulate the circuit, so we have to remove these prescalers and filters. So this is the circuit where there is no prescaler and filter. Let's simulate the waveform. Waiting. So this is the result. We have clock right here and we have a reset button pressed in the beginning. We also have 3 D inputs based on our sequence, and this is the output. The LED will blink one light at a time in turn. So this is the output. And this is the final circuit, including the prescaler and filters. And this is our D button. It goes to filter first, and the end button also goes to the filter right here. And this is our MUR symbol. This is based on the state diagram that has been converted into a symbol file. And that symbol file is connected to this night writer. So here is the connection. The clock from the night writer is connected to the clock right here, the 1 Hz. But it should be different from this prescaler that is connected to our 2 filters. So this is it. We have 6 output for 6 LEDs. Thank you.
Hello, my name is Ilham and I'm here to explain about one-hot encoding. So based on the more version of the state diagram that my friends have explained before, we can get the next state equation and output equation. So we already made the circuit for the next state equation. So this is the circuit with all of these logic gates, and after this we can generate the symbol of this circuit. And now this is the symbol of that one hot state machine circuit, and then we add the input for D, N, and the clock. And this one hot state machine symbol, we connect it to the night mode rider that we have used from the previous milestone. And then we connect all of this output A, B, C, D, E, and F, and then we connect the done to the reset on the one hot state machine. So to make sure that one hot state machine have the same output like the more version that my friends have explained before, we can check it. So this is the waveform. We can run a simulation of it. And by the way, this is the our sequence, the D 3Ds, and we will see the output waveform. And now this is the output waveform. So basically this is one LED, this is the LED A, LED B, LED C, and so forth and so on. This is the last LED F. So basically there is only one LED that on at one time. So this is like the running light. Okay, so before we go to the next part, which is the sequential binary encoding, first we have to derive the state table and get the next state equation and output equation. In order to get that, we have to construct the truth table. This is our truth table, and then construct the K-map. This is the K-map for our first flip-flop and second flip-flop, which is used in the schematic editor after this. And this is the output, the F1 for the flip-flop 1 and the F2 for the second flip-flop. Okay, so after we derive the state table and then get the next state equation and output equation, we can construct the schematic circuit for this binary encoding. This is our circuit, and after this we can generate the symbol for this circuit. And this is the output waveform for the circuit. We can run this simulation. And as you can see here, after 3 clock cycles of when the D is pressed, the output will be 1. Okay, now this is our binary encoding from before. So in order to simulate this circuit, we have to connect it to the night rider mode that we have modified before and connect it to the input, which is N, D, and clock. And this is our output for A, B, C, D, E, and F. And we can try the simulation for the circuit. This is the simulation editor. We can run this simulation. Okay, now this is the output simulation. We can see that there's only one light that on at one time. So this is LED 1, LED A, B, C, D, E, F, and then back again A, D, C, B, A. This is like just like the running like on this simulation. Okay, now I will demonstrate our circuit to our DE2 Altera board. In order to do that, I've already added the prescaler 100 Hz and 1 Hz, and also the filter from the input. The input is N, D, and clock. I already assigned an appropriate pin on our board to our input. Like for this example, the pin N is assigned for the pin P23, and I already assigned the output LED to appropriate pin in our D2 Altera board. And now we will try to demonstrate into our board. And first, I will turn on the board first, and then after that, we will go into our quarters to our programmer window. This is the programmer window, and this is the files that will be programmed into our board. And the device, the board is already recognized by my computer, and we will start the programmer. Okay, it's already said that it's successful, so we'll see our board. This is the button for D, and this is the button for N. So I will try using another sequence that is, for example, N, D, N. The lights will not turn on. And now I will try a sequence for our group is D, D, D. D1, 2, 3. As you can see, the light will turn on and runs. The LED will runs only one at one time, and it will runs forever. There's not stop on this LED. Okay, that's all for our group. Thank you so much for watching.